Let's rejoin the conversation for part two of my interview with Richard Waldinger.
With that framing of history, and can you help give, especially some of our younger viewers, maybe a sense of what were some of these earlier times in AI like, especially given that you've been at SRI your whole career, and SRI is really one of the birthplaces of AI and of all the investment that the Advanced Research Project Administration put into AI with robotics and planning. So I wonder if maybe you could talk about some of your experiences starting out working at SRI in the 70s with all that was going on there and all the colleagues that were working there that now are like yourself, all very well known in the field.
Well, those were heady times. Like it was like artificial intelligence was a new thing, and when I was there, there were only like 3 or 4 places in the United States where AI was done. There was MIT, there was Carnegie Mellon, there was Stanford, and there was SRI. And I don't know whether, at least for symbolic AI, I don't think anyone else was doing it. So it was like, and it was very highly regarded, and there was no trouble with funding in those days, which is the last time I remember being there. ARPA would say, "Oh, just tell us what you want, and we'll send you the money." It was not very competitive at all, and we were very ambitious, and we did robotics and using theorem proving to control the robot, and there was the Shaky project, which was one of the early big projects in our lab, had natural language, it had robotics, and it had theorem proving. And now you will not find a single project that combines all of them. They're all such specialized areas that someone who knows about robotics doesn't know anything about logical reasoning, and natural language is usually a completely different specialty, and it's hard to find people who can bridge the gap from natural language to logic to robotics and fit them into a single system.
I mean, Shaky was really one of the first, if not the first, actually functioning mobile robots, and sounds like it was very multidisciplinary.
Yeah, it could even explain what it was doing. If it solved the problem, I could tell why it had done that, and up until, well, because you told me to do that, was the top level answer, but everything down below had some explanation. So it was you could argue that it had consciousness according to some definitions of consciousness, in that it was aware of what it was doing and could explain it.
And I guess Shaky sort of slowly wandered down the halls at SRI so that people could even interact with it at times.
Well, mostly it was in one room that was its laboratory, but it broke down so often that to make the videos in the old days, they often had to fix the robot in the middle and then have it pick up where it left off, which I think the first video, they had a clock on the wall that seemed to be going backwards at times, because the second part of the video was filmed a day or two after the first part, when they fixed the robot or debugged the program or whatever it was that hadn't been working.
Great issue for common sense reasoning with time flowing backwards too.
Oh yeah, that no reason to assume time always moves forward.
So who were some of your colleagues that worked on that project?
Well, when I joined, I worked directly under Cordell Green, who was the author of the QA3 program, which was a theorem prover that did problem solving, including robotic problem solving. Niels Nielsen was there. The head of the group was Charlie Rosen, who's both Niels and Charlie are now dead, but Charlie was a very inspirational figure. He was very full of enthusiasm, and he started off as a physicist and went into AI as a great new thing. It was quite influential.
And at what point did the Snark theorem prover come into being? I guess it was Mark Stickle that started.
Yeah, that was Mark Stickle, who also died a few years back now. And I had done some work in theorem proving myself, but when I met Mark, he was much more knowledgeable about the arcane disciplines of theorem proving. There was a lot of work that had been done that I didn't know about. So I became more of a user of Snark rather than a inventor of theorem proving myself.
Yeah, but that was, I take it, Snark wasn't actually used on Shaky. Snark came after.
Snark was later, but QA3 was used on Shaky. Snark was used in a number of other things. One of the more practical things, Snark was used by NASA in planning observations for data analysis for interplanetary missions. So they had huge files of data, and they had subroutine libraries for answering questions, but people had to write Fortran programs to do the computation. It'd be like, how long will the shadow be on this at such and such a time on this, if you're on Jupiter and you have a 3-foot tall stick, how long will its shadow be if you know exactly what time as viewed from such and such a spacecraft at certain, they were very computationally intense problems. And the Amphion system, which was done by Mike Lowry and his associates, used Snark to compose Fortran routines to solve those problems. And they were in one mission, they said that half of those problems were solved by programs that were written by Snark.
Wow.
So it was actually quite practical, and it would usually be able to solve the problem in like 2 or 3 minutes once it had been formulated.
Yeah, this is something about the history of science. Whatever's not the hot thing at the moment, we kind of forget about some of the big achievements of the paradigm that has been the previous era's paradigm. Mm-hmm. Very rarely have I heard somebody articulate as clearly as you. Right, here was a really big result that theorem proving came up with to help another major scientific application.
Right. And actually, that's pretty unusual. Like I can't think of too many applications of theorem proving that turned out to be that practical.
And maybe I could also touch on the relationship between SRI and NASA. So I actually worked at NASA for a little bit in the start of my career, moved to Silicon Valley because of Moffett Field being here. And sometimes I feel like NASA really doesn't get enough credit for helping to be one of the engines of growth for the original Silicon Valley. I mean, how do you see NASA's influence having helped Silicon Valley happen, and been also, how did it influence the work that you did at SRI?
Well, I certainly never would have gotten involved in planetary astronomy if it hadn't been for NASA. Coming asking about I think Tom Pressburger came and talked to me, who's still at NASA now doing intelligent avionics, and they've had a variety of different AI projects over the years that have been influential.
Yeah, I had a number of colleagues that were distant colleagues, I might say, that were there at the NASA AI lab when I was, that wound up spinning off some of the companies that were sort of in the original .com gold rush back in the late 90s. So the influence of NASA, I think, needs to maybe be told a bit more widely, and especially this, through partnership with things that you did at SRI, having these different major labs sending ideas and people and sometimes funding back and forth, that I'm sure had a really big impact.
Mm-hmm. Yeah, they had a very active AI group back in those days, and now it's more dispersed to. There's AI components of other ongoing projects.
Right. So looking back at your career, what are the things that you think that you would like to have told your former self, and by extension, what are things that you would like to say to young researchers who are getting started now? What are some of the lessons maybe that you've learned about the process of science or uh, developing a career in science?
Well, one of the uh, I don't know whether I've actually learned it, but I was in order to maintain funding, I was always looking at problems that I wasn't terribly good at, and I might have done better sticking to the problems that I was good at, and letting other people work on the other things. There was always a push to do more applications and to simplify the problem so that you could get practical results, whereas that might be a distortion of in order to get something that's flashy, like I remember, well, for programming, I spent a lot of time looking at not doing conditional programs and not doing programs with recursion or iterative loops, just because those were hard problems, and I was staying away from the hard problems so that I could get better performance. And when the hard problem is still there and it still needs to be solved, and just ignoring it doesn't make it go away, and eventually you have to face up to it.
Which is maybe a good lesson also for the field generally. I mean, all the problems that you and to maybe some extent I have been working on are the hard problems that are not the popular problems at the moment, because they're not easily solved. They're problems in higher level cognition. And it's always an interesting thing. I wonder, am I having enough success working on this really hard stuff that I should just stick with it? Can I be confident that we're going to get a breakthrough? Or should I just work on something that's already kind of well known and really popular right now? That's, I think, an interesting challenge for any researcher to think about. When do you change your path, and when do you stick with what you're on?
I know Einstein said something like that he has little respect for the scientist who looks for the thin part of a board and then drives a nail through it. And that's sort of an analog to looking for the low-hanging fruit and solving the easy problems. And there's some justification for it, but on the other hand, you still have the other fruit that's out of reach, and you never get to do that if you're always looking for the easy problems.
Yeah, I mean, imagine if Geoffrey Hinton or Rumelhart and McClelland or any of the other early luminaries of neural networks and machine learning had said, "Oh gosh, nobody's giving me any funding. This stuff is too hard. I guess I'll just do something else." And then we have had this whole explosion of such a rich area of study in artificial intelligence.
Yeah, I think also DARPA tends to look for large projects, and in some way you lose. It's all interesting, but you sort of you get forced into the lowest common denominator of what everyone can do to get something that justifies spending so much effort on this one large problem. And it worked like something like Siri was the result of a large DARPA project, and it turned out to work pretty well, at least for the things that it can do. And but it sort of ignored some of the deeper problems. And Siri doesn't actually understand a lot of the things it does, and if you push it too hard, it'll do things that no person would consider reasonable.
Yeah, my take on it is that it seems like it does a few things, and that it's more that the people have adapted to the things it does well than Siri really understanding how to be the most helpful it could be.
Right, and it's not getting any better.
Yeah. Yeah, it's another challenge. Is how do we keep some of these advances moving? It seems to me the machine learning approach is fantastic for getting you results fast, but that we need curated approaches, symbolic approaches, uh, to continue making progress. Because if we try to learn everything from one data set each time, um, or just continually larger data sets, we get great performance in that data set, but then outside that data set, we don't get the generalizability that it seems to me that the symbolic approaches have inherently. Well, I'm kind of preaching to the choir, right? So we're very much on the same page. And
Yeah, that's right. We don't have anything to argue about, really.
right. So sometimes it can make for a more exciting interview if you actually have some differences of opinion. So then let me suggest that we move to what's always fun to try to do, if you're willing, which is to make some predictions. Where do you think the field is heading? Where do you think AI in general is heading? And maybe where do you think symbolic reasoning and automated theorem proving might be headed as a subfield of AI?
Well, of course, we should point out that many people have tried to make predictions without any great success. Is the quotation that it's especially difficult to make predictions about the future. But and I know my advisor Herbert Simon was famous for predicting, like in somewhere around 1970, that within 15 years a computer would be the world chess champion, and it didn't happen. It may have happened in 30 or 40 years, but not in the 15 years that he predicted. And then there was there was Watson's prediction that the IBM Watson predicted that there was only need for 5 computers in the world. That's all he could anticipate anyone selling in the future. So it's a dangerous thing. But I think, well, for theorem proving, I think we're theorem proving is one field which can take great advantage of parallelism, and we're just beginning to see machines which have very many processes that can all collaborate on a single problem, and that's something that we can expect theorem proving to do well. So to take advantage of parallelism, so I would expect it to. We've already seen great advantages in. I mean, new systems are much better than old ones, and I think we've only just begun to see what reasoning can do, and so that'll be exciting. And as you point out, integrating reasoning with other approaches would multiply the effect. So I think we can expect to see. I think we've only seen the beginning of what artificial intelligence can do, and I know it's easy to be overly optimistic, but I can see at some point in the future the end of all work as machines become more and more competent, and there won't be anything that people can do that some machine can't do better, including doing therapy and art and other things that are regarded as human territory. And then the people who are worried about the future of humanity, what's going to happen to humanity as machines get to have superior abilities, and will intelligent robots want to preserve us when they're much better at doing things than we are? Will we be regarded as like pets of the intelligent machine? What is the future? And I know the futurists like Kurzweil and this Singularity Institute people talk about the transhumanism, where there's some sort of merging of humanity and machines into some kind of super being, which will combine the benefits of both. But I wonder how much of that will actually be human, and how much of that will be machines taking over the machines themselves becoming more human. And is it something we need to worry about? Like, are we really concerned about whether humanity will last forever and ever? But on the other hand, there's no reason to expect that machines will want to get rid of humans. Why? I think machines will naturally evolve to survive in space, which is something that people don't do very well. But for a machine, being in space would be this great source of energy. There's free air conditioning and lots of minerals to build more machines out of. So there may be no competition between humans and future intelligent computers. But of course, this may be something that doesn't happen for hundreds of years, or it might be that humans will wipe themselves out before they develop machines that are smart enough to save them or destroy them.
Well, I take heart from sort of the first part of your answer, which is all of the people that have been wrong about the predictions about how easy it will be to really create intelligence. So when Ray Kurzweil talks about this singularity, and he's estimated it at various points in the future, but I think not too far off, with something like 2030 at one point, he said. And
yes, I don't think we're going to be there.
No, I don't think we're going to be there either. So the philosophical problem, or the dystopian problem, I think is so far off in the future. We need to discuss it, but maybe not worry about it too much. And I look forward to the future where our systems simply get better, and there's lots of work for people like you and me trying to make them better.
Yeah, let's hope we don't work ourselves out of existence.
Indeed. Well, I think that's maybe a great place for us to pause the conversation. This has really been fascinating to both talk about the future and the past, and also touch on the advances that are here in our present. And it's really been an honor and a pleasure to have you on the show to talk about all these things. And thank you very much.
Okay, well, thank you for having me. It's been really fun to talk to you, and I hope to continue our discussions at some future time.
Absolutely. Me too.